Hello everyone, and welcome back to Winter Data Meetup. I hope you are finding the sessions insightful and inspiring so far. Meet Roland, a data expert building powerful analytics tools. Discover Huey, a fast and lightweight pivot table application powered by DuckDB and WASM. See a live demo and learn how to analyze huge datasets right in your browser. And before we start our session, I'd like to take a moment to ask you for your support and growing our community and recognizing our speakers. If you enjoyed today's discussion and want to stay updated on upcoming events and talks, please take a second to hit the like and subscribe buttons below under this video. Your participations not only acknowledge our efforts but also helps us reach a wider audience, allowing more people to learn from these insightful discussions in the world of data. Also, in the video description, you will find a link to talk page where you can share your feedback, award speaker a badge, and trade the session. Your input is incredibly valuable. It helps us improve future events and ensures our speaker get recognition. And yeah, they deserve it for their hard work. Additionally, we'd like to hear from you thoughtful the talk. Uh, if you if you have any questions or insights, feel free to drop them into the chat, and our team will actively monitor it and pass to the speaker. And we'll discuss the questions with the speaker during our Q&A session in the end of presentation. Your contributions make the discussion even richer, and so don't hesitate to participate. And now let's welcome our speaker to share with us his valuable insights about this interesting tool. So, Roland, floor is yours.
Joining me at the DataZen Winter Meetup. I'm going to talk about Huey, and Huey is a pivot table app, and yeah, we're going to see all the ins and outs of it. So first, I'm Roland Bouman. I'm Chief Software Engineer for EPAM Systems BV, and I live and work in the Netherlands. And my focus is mostly on business intelligence, data warehousing, data integration, all kinds of stuff around data, all around the stack. And you can find me on my personal email. I have a blog and on LinkedIn. Okay, the agenda for today. I'm going to talk a little bit about something called the small data trend. And I'm going to talk about DuckDB and how DuckDB is a tool that is on the rise, and how it makes sense to use this in a modern data lake environment, and how it can help to work with your small data needs. Then I'm going to talk a little bit about WASM, which is basically the web assembly paradigm, which allows native binaries to basically be compiled and run directly in a browser, in a modern web browser. So there is a WASM compilation for DuckDB, and I'm going to talk about all that. Then we've got Huey, and Huey is basically the focus of this talk, and it's a non-trivial analytics app that runs in your browser and uses DuckDB to analyze comparatively pretty large data sets. And with pretty large, I mean larger than the working memory. We're going to talk all about that. Then I will do a live demo of Huey. I prepared a script. I am not sure how far I'm going to get through it, but I'm just going to give it my best. And then, in the remaining time, I will talk a little bit about how it works under the covers. So if you would want to build your own DuckDB WASM application, how to get started and how to get the basics of running a query and analyzing data. I will conclude with some takeaways, and there will be room for some questions. Okay, so without further ado, let's get started. Okay, small data trend. So if you're a little bit like me and you see this slide, there's a few things in here that should worry you, because one of them is I'm talking about a trend. With a trend, whenever somebody says, oh, there's a trend, I'm always like, okay, who decides what is a trend? How do you know that something is a trend? Right? It's good to be a little bit suspicious of those words. And then the second thing is that I've got 2 links in there which point to manifestos. Now, whenever in computing people come up with manifestos, we've seen the Agile manifesto, and I'm sure there's a big data manifesto, and so on. It means that people are engaged in politics or religion or something like that. And you should be a little bit suspicious to look for what's the merit and what are we talking about. Now, when I heard about this small data trend, I was suspicious like that. But when I heard a little bit about what it means and what the people that are saying this stuff are aiming for, it resonated with me. I thought, yeah, that's actually makes good sense to me. And so I'm going to explain a little bit what that is. And I think we should see this small data trend. Of course, the name is not chosen accidentally. It's chosen as a kind of a contrary to big data. And I think the best way to understand this whole concept of small data is that, we live today in a post big data world. So big data is a thing. All kinds of companies are using big data for better or for worse, and this has led to all kinds of architectural paradigms and ways of managing data, ways of analyzing data. And I should say that there is a trend that people used to think like the more data we've got and the longer we retain our data, the better results we're getting. And that turns out not to be true. At least this is a statement. You can agree or disagree, but I think it's true. More data in many cases means more of the same data, and it's not so that the more data you collect, the more value you're going to get out of it. And it's more, in fact, so that the most data that you're actually using is recent data, and the most value is what you get from the recent data slices. Of course, there may be exceptions to this rule, but I think this, at least in the work that I do, this holds true. Most of despite the fact that we have the capability of doing big data, most of the analytics and the BI is still around, mostly operational decision streams and basic reporting. It's just now we're doing it on data lakes rather than data warehouses. Now, most data sets aren't big. I'm going to back that up with some facts in later on, but for now, this is just accepted as a tenet that if you look at what people are actually doing with their data and what kind of queries they're running, then it turns out that even though they have a lakehouse which is huge, typically a query does not scan all of that, and actually it typically scans a minute piece of it for some very specific result. And small in this case means in the gigabyte range, and maybe tens of gigabytes, but not hundreds of gigabytes. Of course, there are some use cases where you do have hundreds of gigabytes, but majority of it is not like that. And we're going to see some facts later on to back that up. Now, at the same time, even though we have these powerful, cloud environments with clusters and multi-parallel processing and so on, it turns out that our workstations have actually grown as well. And single machines, keep getting more cores, keep getting more memory, and it turns out that you can actually do a lot with just a single node, and even you can do a lot with your own workstation, your own laptop or your own desktop computer. And the idea is that with these tools, these modest tools, you can actually avoid, still build all kinds of interesting data-intensive applications without having to deal with all these complex distributed data processing environments. And especially for the development phase, when you're developing some application, you don't need, in many cases, you don't need that cluster. You can just still develop your queries just on your local machine with no hassle and no waiting for remote systems to set up and tear down. And then there's this thing that, just because we're doing so much with cloud and with distributed data applications, it doesn't mean that every application needs it, right? And if you don't need it, you might be better off, certainly cost-wise, by not doing it. And if your data set is small, in fact, a distributed computing solution will also not be good for the performance. It's much better to have it in a single node close by and use that. And for development, it actually could be actually a cost saving, right? If you now have people working in, let's say, a Databricks environment, and they're using files and trying to make sense of what their data set is, and they're using the Databricks cluster to kind of just do data previews and that kind of stuff. And it might not be a lot, but in the end it adds up, right? And you could have also done that on your laptop, right? And that would have saved you in the end some cost. So that's kind of the field where we should understand this small data trend. Whether it's really a trend, I leave up to decide to the analysts. But I thought many of these points made by the people writing these manifestos ring true to me, or at least make sense to me. Now, I recently ran into an article from George Fraser, the CEO of Fivetran. Fivetran you probably have heard of. If you haven't, it's a big data integrator that basically gives you data warehousing and data ingestion as a SaaS solution. And he wrote a very interesting blog on the fivetran.com blog. How do people use Snowflake and Redshift? The reason why I'm talking about this is because Snowflake and Redshift are, I would say, the typical analytical database management systems that profile themselves as big data engines, right? Big data machines. Now, if you look at, so Fraser took some data and analyzed that, and made some guesses about, or made some inferences about how people are actually using these big data tools. And it turns out that these data warehouses are not really used as database management systems in the traditional sense. They are more used as really ETL tools, just to ingest and transform data and deliver it to some format that can be reported on or analyzed by analytics applications. And the second observation, which I think is very interesting, is that most queries really are small. So there's a graph in here that actually shows that. Let me point it out. So what we see here, on the horizontal axis the amount of data, the volume of data scanned in the query, and here we see the number of queries that are using that, and we see that the peak really is around 32 megabytes. 128 megabytes, like under a gig, right? So many queries are in this range. And people can still do a lot of those queries, but the fact is, one single question that they ask of the system is always is mostly in this small to medium data range, and the gigabyte range is all the way up there. And sure, there are some things that happen in terabyte range, but it's like a very tiny minority. So the gist of it is that all these kind of queries, if you would have had the data, nearby, you could have done locally, and it would have made a difference on the bottom line, because, as you well know, Snowflake and Redshift, they charge per query and per usage, so it adds up. And this is just a little aside from people not writing those data manifestos, where George Fraser says, it's actually, it might be true. It might be an actual thing, small data. Okay, now we're going to talk a little bit about DuckDB, because what's DuckDB? DuckDB is a fast in-process analytical database management system. And why is that interesting? Well, you might know we have all these typical database management systems are client-server, Snowflake, Redshift, HANA, all kinds of typical database systems. They work with a server that is the actual, central hub for taking in requests and for either doing the query, either doing the data processing or handing it out to worker processes. And there's clients that actually ask the questions. Now, DuckDB is not like that. It's in process or an embedded database. That means that the application that does the data processing runs this DuckDB software as part of its process. So there's no client server happening. It's all happening in the same process. And there's a very famous and popular in-process database that most people have heard of. It's SQLite. And SQLite is embedded, but it's not analytical. It's used for transactional workloads or single record operations, whereas DuckDB is analytical and especially geared towards OLAP. So that makes DuckDB unique by having this combination of being clients by being embedded, not client server, and analytical and not transactional. Now, DuckDB is a database management system technically. You can and it's relational, so you can create tables, and it supports SQL, and it has database files that you can actually use as an actual database. But it's more appropriate to use it as a analytics engine. So something like a piece of software that you just use to get some data processing done. Now, how does it do that, and why is it so fast? It's because it's column-oriented, and it uses vector-wise streaming of the data. And because it's streaming, that means that often cases you can process data sets that are larger than memory and do that efficiently. And the DuckDB typically runs so in process on a single node. So there's a single process running on a single machine. But there is still parallelism in the form of multi-threading. So whenever DuckDB has a chance, it will just use multiple threads and use those to divide the workload. Yeah, in process already mentioned, so it's like SQL but for analytical workloads. And then what DuckDB does, and what it does very well, is that it has a modern standard SQL. It's kind of like PostgreSQL, same level of standard support, but it adds a lot of enhancements that favor expressiveness. So if you know a little bit about the history of SQL, it was originally designed as a language for business users that they could talk English to their data. And that kind of usage is actually completely superseded by UI tools. But DuckDB really tries to make SQL a little bit easier to use, and it adds a couple of enhancements that I can't go into deeply because it's a whole chapter by itself. But it's something that you could check out, and it adds some really nice features that make it easy to use it, and especially use it as an interactive language. So you can just really type your question and get your answer in an answer and question dialogue kind of way. It has a very rich data type system, so it supports structures and nested data types, JSON types, all those kinds of things, which make it very useful for all kinds of data integration where you have to deal with that kind of data in the source form, but also to do some pretty interesting algorithms. And furthermore, DuckDB is extensible. So it's built as a plugin architecture, and all kinds of features are not built as part of the core, but as part of an extension. So you can install them when you need them and discard them when you don't. Last but not least, DuckDB is open source and it's free under a permissive MIT license, and that means that you can do basically anything you like with it, as long as you acknowledge the copyright. So it's free of charge. You can embed it in your applications. You can copy it. You can sell it, even if you want to. And yeah, finally, I should say DuckDB is originated in the Center for Maths and Informatica in computer science, I should say, in Amsterdam. And this is, if you know the institute, this is an institute where many fundamental database technology has been researched and developed. So, for example, some people that started Snowflake studied there. Action database was created there. MonadDB was created there. It's a very interesting institute, and I think actually Python also originated in this institute. So those guys, they made DuckDB. Just a quick overview. So DuckDB is simple and small. It's zero install, which is great. We work with many customers who have lockdown laptops. We can get DuckDB to run there easily, but just downloading and unzipping. There's no dependencies in DuckDB. It's a completely self-contained binary, and it's small. It's like 25 megabytes, something like that. It's really fast. If you compare to alternatives. And like I said, multi-threaded execution, larger than memory data sets. All the SQL features. It supports Parquet, CSV, JSON, and quite a bit more. Many of the list is actually not easy to give, because many of these things are supported in extensions. Parquet, CSV, and JSON are core extensions, so they're always present. And that makes it already quite useful, because converting from and to Parquet without any dependencies is just a breeze with DuckDB. The structured types, like I said, extensible, so you can extend data types, you can extend functions, file formats, you can even insert SQL language features. It's available for all modern architectures. There's drivers and clients for many different languages. And a lot of them are core, some of them are community contributed, and free. So great stuff. Now let's talk about WASM, the WebAssembly. So I already mentioned a little bit. WASM is WebAssembly. It's a binary instruction format for a kind of a virtual assembly machine. What this allows you to do is it's a compilation target. So you can have programs that are written in C or C++ or Rust or one of those typical binary languages, and you can compile to WASM. This allows these applications or this software to be deployed and run inside a browser. And then, as you know, modern web browsers all have pretty advanced JavaScript engines. And the WASM software that you run in the browser, the WASM modules, they're integrated in the JavaScript framework, so you can, write JavaScript applications that use these WASM modules. And that basically means that you now have a JavaScript interface to running programs that would normally be run as a binary. Now, there's an official DuckDB WASM distribution, and these modules are available on content delivery networks and NPM. And you can this means that you can run DuckDB in your browser. It's just that simple. Now, using this DuckDB WASM distribution, I built Huey. And what it is, it's a lightweight, table browser app, and you can use it to build pivot tables. And that's not in itself that interesting, but it's interesting because DuckDB can handle large data sets. So you can build pivot tables in your browser on pretty large data sets and pretty diverse kind of data sets. So I try to make Huey just like DuckDB, so simple, small, and without the dependencies. You can run it locally, just from your local file system, or if you want to, you can deploy it on a web server. It's just like DuckDB. It supports Parquet, CSV, and JSON, and I recently added Excel, which is still experimental. You can load data from URLs, and then it requires that the URL is served from a server that passes the right course headers, because it is not. It's still a browser app, so you still have to deal with all the same origin policy and that kind of stuff. Try to make Huey fast and user friendly. I hope the demo will convince you or not. And the idea for Huey was to make it as simple as possible, but allow you to do more complex things when necessary. And Huey is just like DuckDB. It's MIT licensed, so it's open source. You can do anything with it you like, as long as you acknowledge the copyright. Okay, we're going to go to a live demo. So what you see here is a screenshot. I'm not going to talk much about the screenshot. I'm just going to go directly to the live demo. So I'm just going to leave the presentation for a second. Okay. And what I want to show you is I'm going to go to my browser, and I'm going to go and get Huey. So Huey is developed and hosted on GitHub. It's over here, so github.com rpbouman/Huey. And let me just talk a little bit about the project itself. So first of all, we have, of course, this README. README is the official documentation. It's just one page, not much of it, but I think it covers all the basics. And it already says it here. So browser-based application for exploring and analyzing data. And what you can do immediately, if you like, is you can go to this live link, and this will host the latest stable release as a GitHub page. So you don't even need to install or download it. You can just immediately start using it by just going to this link. I already pointed out here, so it's MIT licensed, so it's completely permissive, completely open, free. You can do with it what you want. I should point out the releases. We have a couple of releases here. The current stable release is 1.0.0, and that's also the one that's deployed as the live version. We have a couple of more development releases, so you can always look up which releases there are, what changes there are, and so you can to actually get it. You would pick the release that you're interested in and go to assets and just download the whole thing as a zip, and unzip it. Of course, if you're a Git user, you can also just check out the repository and use it to get updates. And right now, I'm just going to download the current development version because that's what I'm going to use to demo it. So I just go here and I do download the zip, and I'm going to put it in our nice DataZen folder. So I'm zipping it now. So this is where we got it. You can see zipped. It's just 200K, not large. Let me unzip it. I hope this works because sometimes 7-zip complains a little bit. Yeah, here we go. So this is it. This is the entire thing. I can actually show a little bit of the structure in here. So we've got a GitHub repository, and we've got the source. The source is actually where everything happens. The README is in there, the license in there. And the structure is not terribly interesting. What you need to know is that you need to go to source and then just open index.html. Now, as you can see, just open it directly in the browser. Currently, I set the zoom a little bit higher, so it's usually a little bit smaller if you're running it on your own desktop. But for the purpose of this presentation, I zoomed it up a little bit. So let me talk about the user interface a little bit. Again, so you can see we're just running it from our local file system. So there's no connection with the internet. Once Huey is loaded, and once you've loaded the first time, the only dependencies that it has is DuckDB, WASM, and some icons. Once those are loaded and once those are cached in the browser cache, you can actually run this without even being connected to the internet. We have a toolbar with some functionality over here, a couple of buttons that allow us to acquire data. We have an about box, we have some settings over there, and we have this data source tab, and it gives you a hint on how to get started. So drop some files here or click the upload button. So this is the big upload button. We click it, and now I've already prepared a couple of CSV records over here. So we can see here we've got 50 meg CSV files. 50 meg is not a lot, but if you build a browser app and you're loading 50 meg, and you do it carelessly, you might get into trouble. But in this case, it's quite okay. I just choose it. You see it starts uploading. In fact, it's not actually uploading it, it's just registering the file with the DuckDB WASM instance that's inside the application. And you can see once we acquired the data set, we see here in the top that, okay, this is the data set we're looking at. We see that some things in the UI changed. We now have an extra attributes tab, which gives us all the attributes that are part of our file. And we see the query UI, which is basically our query builder. I'm going to talk about that in more detail in a second. First, the first thing we want to do is just get a little bit of visibility on our data. So to do that, the quick query menu has also become available since we loaded the data. And here we have a couple of options. We can do column statistics and data preview. Column statistics is like a profile of the data. I'm not going to go into that now. You can try that for yourself. I'm just going to do a data preview. So I just click it. And you see it loads the data, and we can kind of get a feel of what kind of data we have here. Now, it's of course a sales data set, so it's a retail kind of data. We see a region and country, which kind of point to the fact that it's like a location dimension, item type, the kind of objects that we're selling, the sales channel, so how are we selling them? Then a couple of things that have to do with the order, so order priority, order date, and order ID. And we can scroll a little bit, and we see shipping date, and then finally we see a bunch of metrics: units sold, unit price, and revenue and profit. We can see them here as well. So now we've got a kind of a feel of what this data looks like. The data preview will only show us 100 rows. That's by design, just to get a quick view in the data. Now that we've kind of seen what kind of data we have, it's time to build an actual query. So let's do that. I'm going to go back to the quick query menu and clear the query we have now. The data preview was just there to just quickly get an insight in the data. Now I'm just going to talk a little bit about how this query paradigm works. So I said, okay, we have here the attributes, and the attributes are basically the columns of our data set. We can tell by the icon what kind of data it is. So text means it's some kind of text label. We have a calendar, that means it's a date. We see, the numbers, which means it's an integer. And here we see the decimal numbers, and this means, these are probably, decimals or doubles or something, some measure, some metrics, right? Now we see for each attribute a couple of buttons, a couple of action buttons. These are the access buttons, and these correspond to the query UI, right? So, the icon over here means, if I click it, I would add it to the rows axis. And the other one, I would add it to the columns axis. Now, let me show what happens. I'm just going to start with country. I'm just going to add it. And you see, clicking the button adds it to the axis. And now it adds it to the pivot table, and we see the values for the country. And okay, so that's nice. Let's add region as well. So I'm going to do that. So now I have country and region, and you might notice that the region is in a way higher up in the hierarchy than country. So we've got Europe and Albania as a country inside Europe. So we've actually got the columns exactly the wrong way around, right? So once the items are on the axis, we can move them by using these buttons over here. So I can move this one to the right, or I can move that one to the left. Let's do that. It requeries, and now you see that it becomes a little bit more easy to see, because now you've got Asia, and everything that's inside Asia all comes here. And because Asia is a repeating value, we see this little ditto mark. Yeah, you can all configure that in the settings if you don't want to see that, but that's by default what you see. And yeah, I'm using these buttons over here. The idea of using these buttons is that it makes it easy for devices where you don't want to drag a lot of items across the screen. When you have a tablet, that kind of thing, you can just tap the buttons and do your stuff. We also could have, there's a couple of more things we could do. We could also have just dragged the items there, move them like that, or we could have dragged them from here and moved them like that. So there's all kinds of classical UI paradigms that are supported by this app. I'm going to show a couple more as well. Once the items are on the axis, we can work with them. We can remove them, or we can put them to the other axis. So let's try that. Let's put the country on the other axis, and now you see we've got countries over here and regions over here. Not very useful, but I'm just demonstrating that you can do that. Let's get it back over here. We can also do it for the entire axis. So if I hover over this icon, you see the icon flips. It means that, okay, I can move this entire axis to the other side. And all these options are also available from the query menu. Just flip them. And removing them is also possible from here. Okay, so now we've got region and country, and those are the location dimension of our data. Now let's take the other dimension. Typical dimension for dimensional data is time. We have two different time dimensions. We've got order date and shipping date. And there's always something interesting with dates, because here we see region and country, which is location, but it's split in two different columns. And order date, we can put it on the columns just to see what happens. And you see that, okay, we get all the dates, and because it's a date, it's on the day level. But it's not very useful, because we lack this hierarchical view of the data. It would be much more useful if this date would be split in its different parts, so we can navigate it from high to low. So in order to cope with that, Huey has this concept of what we call derivations. And it's like, okay, so this is the raw column, and then we added that just now and saw that was not very useful. But what we can do is we can expand it, and then we see that there's all these derived items. So basically, the things you find here below are calculations or transformations applied to this column, so to make them more useful. And in this case, what we're going to do is we want to say, okay, we want to go to the date fields, because this will split out our date into separate components. And we see here the year and the quarter and the month name, all kinds of different aspects of the date. And that's what we want. So we want to do the year. We want to do the year on the columns axis. And we also want to do the month name on the column axis. And now it starts to really become a little bit more useful. Now that we have these items on the axis, we see that we have all these intersections. And that those are the cells. Right now they're empty. There's nothing in there. But we should imagine that on the intersection of the Asia, Bangladesh, and 2010 January, there's a whole collection of sales happening. And right now, if we want to see something on that, we don't want to see the individual sales. We want to see some kind of aggregate calculation on them. Now, we always have for free a generic count aggregate, so we can just add it. And you see, the aggregates are always on this third axis, on the cells axis. And that's just how it works. It's a pivot table, so that's just how that pans out. And now we see, okay, we have the values over here. We see for all of them, we see the counts. Other useful aggregates would be, the profit. So let's get that. Oh yeah, we have the search interface over here. If there's a lot of columns, we can look for them using the search. We see the item over here to add it to the axis, and if we hover over it, we see that this is like the default aggregation for this column, and it's sum. So we add it, and now we've got two aggregates on our cells axis. So Yeah, just a little quick one. You see that, okay, the cells are on the intersections of both axes, which is fine. But we still see that the headers of the cells, so count and sum of total profit, appear on either one of the axes. And right now they appear in the column axis, which is usually a good default. But if you want to, you can actually move them to the other axis as well, and it looks like this. I just click it, and now we see that, okay, we've now the countries over here, and now the metrics are on the rows axis in the vertical direction. Just it doesn't change the information; it just changes the layout, right? And so you have all that stuff available. Okay, yeah. Now that we have some of these items over here, it can be useful to get a couple of totals. So, for example, we see now here Asia. We can scroll a little bit. Whenever we scroll, what happens is Huey will calculate the area of the screen and only do a query for just the part that you're seeing over here. So the actual complete result is much bigger, and we can see that by the scroll bars. So with the scroll, we can navigate through the entire data set like that. Okay, let's add some totals. So we've got Asia over here. We've got other countries over here. So what we want to do is we want to see the sum of the total over all these countries. So we just go to the country item and we just click the totals item, and then what it does is it generates a total for that item. And of course we can do the same for the month. So we just do that. And now we can see at the end of the months the total for the months. And yeah, if we would want to have a grand total, we would just add more totals. So add the total for this level and add the total for this level. And then if we scroll all the way down to the far right and bottom part, we see the grand total over here for count and for sum of total profit. Okay, now let's do one more thing. Sometimes it's useful to just, we're seeing a lot of data now, and we don't always want to see everything. Sometimes we're interested in just a tiny slice of things, so we're gonna, do that. We're gonna filter a little bit. To do that, I'm just now gonna use drag and drop. So I'm just gonna drop the region to the filter axis. And when we do that, the filter axis is a little bit special because, the other axes are like an item can only appear on one of the axes, but the filters is different because it could be that you want to filter on something and you don't want to see it. And it could be that you want to filter on something and you do want to see it. And that's why the filter axis allows you to do both. When we add a new item to the filter axis, the filter dialog pops up. We have a few elements in here. We have, the type of filter. So we want to do include, exclude, like, not like, and so on. We have a list over here that, this list here shows you actually all the values that are in that column. It doesn't show you literally all the values. What it does, it does a pagination thing, but right now we only have a couple of values, so you don't see that. What we can do is we can search. We now have a pretty modest amount of values, but I'm going to use it anyway. I'm just going to type an E. And what happens is that because we've got wildcards on, it will just search for all the values that have an E inside. And we find these two. And to filter on them, we need to add them to this filter value list. So to do that, I just click it, and it gets added there, and I click it, and it gets added there. And now that we have these two values there, we can apply it to our filter. So let's do that. So we apply it, and we should see now that all the Africa and so on are gone. We just have Europe and Middle East left. We can also do more advanced filtering. So if we add, for example, the month, and we want to see only the last quarter, right? We could have actually gotten a quarter item in here and filter for that, but now I'm just going to use the month to show off that you can use between queries. If we choose between, it means that the condition is that the column will be between the values that we chose. So when we choose between, we get two value lists, the from values and the to values. And I'm going to choose October. And as you can see, as I add the value, it gets added on both sides, but this one is selected. So that means that I can just click this one to get that one updated. So now we've got the period from October to December. And yeah, as you can see, the text value October and December. October is higher, than December in terms of text, but that's not how it works, of course. Below the covers, it actually filters for the month, number. So we apply it, and now we've got left only October, November, December. Okay. I want to talk a little bit about, so we've got now adding items, rows axis, column axis, cells, filtering, and totals. Now I want to talk a little bit about what's happening here in the top, because whenever we change our query, we see that there is a hash happening. And this is basically the entire query state added to your URL. And what this allows you to do is it allows you to use the back and forth buttons. So I can use back, and we kind of get a rollback of our query history. Yeah, so because it's adding the items, it's not the best example, but let's go back. Okay. So you can see you can undo and redo your query by just browsing them. And we can just bookmark the query and store it in some place that we remember later. And that means that now we can go to our bookmarks folder and just open one of these saved queries. And when I do that, it will just start loading Huey again. It will prompt you for the data, because the data is of course not in that URL. So we still have to find the data. And if we do that again, then our query gets restored. So this way, you have your query there. Okay, I want to get back real quick to this. Oh wait, I see that the zoom has gone away. Okay. So I see that I'm running a little bit short on time, so I need to make it quick. I will continue the demo for 3 more minutes, and then I will go to 5 more minutes presentation and some 5 minutes questions. What I wanted to focus on is, okay, so we can do back and forth and store the query and share it with others. That's a thing we can do. Another thing I want to focus on is, okay, so I said that we have these filters over here. Let's go back to that Middle East and one of the nice things about the filter axis as well, once we added filter values, you see that this item becomes expandable, and we can actually have, so we see that there's 2 values in there. We'll expand it. So now we have the filter and we have visible which items are there, and we can actually enable and disable them without throwing them away. So, and this also gets persisted in this query hash. So you can just, share it with your colleagues, and they give them a kind of a mini dashboard that they can use to quickly go over this. Okay, I'm going to go one step back. We still now, how the basic functionality of placing items on the query axis works. We see filtering, totals, and so on. We'll go back to the data sources, because data source, we loaded the CSV file. We have some options over here. We can export the data file. I'm not going to go into that now, but this is something you can do. Export to JSON, export to Parquet, and so on. We can have some settings in there. CSV reader parameters, and if there's errors, they would end up in the regex folder. We can throw it away and we can analyze it. I want to just add a few more data sources. We started by adding one data source, but we don't really need to do one. I can just select a couple of them, or in fact, I can select a whole lot of them. And if I do that, you see it will just in bulk start uploading these things. In this case, they're all going to end up successfully, I hope. And the thing is, of course, this is a very common pattern where you have a data set which is partitioned by file, by some date or some location or some kind of item. And when you have multiple of these data sets that have the same column layout, the same columns and data types, the same signature, then we could apply the same query on different data sets, right? So now they're all loaded. You can see they're all here in the data sets. One of the things that we get for free is because Huey recognizes that all these have the same data, the same signature. So it creates a bucket that you can query as if it's a data source, like a big union of all these data sets. And we have them over here, all as separate ones, but they're also now here in the menu. So I can now use the same query and apply it to the data set of 2011. So this is another way to kind of browse through your data using the same query. And so that's one of those features. Okay, I'm running really short on time. There's what I wanted to focus on. Okay, so far we've seen a pretty modest data set. It's not that big, but we can actually do big data sets as well. We can do Parquet, and I've got here the NYC taxi data set. These files are 500 megabytes each, so half a gig. And I can easily get a set of them that are larger than my working memory, because you have to think the WASM instance can only use 3 gigs of memory. So if I select a couple of these, it will actually start registering these files and making them accessible. And you can see this is quite a bunch of big files that are just being registered in the browser, and we can start using them. So they're there. So it's pretty quick. Let's go to one of them. Let's take this one, and let's take a count. See, boom! There's 18 million records in this one, which is quite big. Now, of course, this is a little bit cheating because it's already stored in the file, but we can actually analyze this as well. And you can see, it's only 20 million, but still, in the browser, and pretty quick, I think. Let's see if we can do a few more. Let's get some bases. Okay. Now, we have also support for JSON, and that would actually allow you to also work with nested data sets, but I'm not going to go into that today because it's a wholly separate chapter. So this was just a demo. I'm just going to return to the presentation and give it a couple more minutes and leave a couple of minutes for questions. And I'm terribly overshooting. Okay, let me get back to this. Okay. So we saw the demo. Okay, how is it done? There's a couple of steps you have to do. You have to load and instantiate the WASM, DuckDB WASM object, register data files, and run queries and then consume the results. That's really what I wanted to show. How does it work? So I use DuckDB from the CDN. So JS Deliver CDN has the WASM module. You just import it. And yeah, there's some boilerplate code in here. I did not invent it. I just took that from the website. There's very good documentation for it. You just run that, and then we can instantiate the database over here. And then once we've got the database instance, we can make a connection, and then I hoist those variables into the window so that I have them available everywhere. Registering a file is basically a call on the DuckDB instance. So we took the instance that we instantiated in the previous slide, and yeah, again, we have just some parameters that we need to, it's all documented, we just need to do it. So we took the file from an input element, so regular HTML file element, and just add them to it. And when I should say one thing, all interaction with the DuckDB library or instance is always asynchronous, because DuckDB does everything in a worker thread. So that means that your UI always stays snappy while the work is actually being done in a separate background thread. Now, once the file is registered, we can just treat the file as if it's a table and get a result. And once we've got the, we can, Yeah, okay, this is actually the same thing, and just doing a query, and we've got the result. The result is returned in something that looks a lot like arrow data sets, and yeah, this is how you can consume it. It's just a result set. It has num rows as a property, so we know how many rows are there. We run through the rows, we get the first row, and then finally we just go to the fields and consume them. And I'm gonna stop right here because I'm terribly over time. I want to leave 5 minutes for questions. So I just quickly, we have a couple of key takeaways. Small data, DuckDB is great for small data. DuckDB WASM is great for running small data in your browser. Huey is a non-trivial end user facing analytical browser app, and it's built on top of DuckDB WASM, so you can take a look on how that works. Here's a bunch of useful links. Huey GitHub project, Huey live demo, DuckDB, DuckDB GitHub, DuckDB WASM, and so on, Small Data Manifesto. And here is a few links of our sponsors for today, Global Cloud Community, Data Storyteller, and Tadata. And I thank the DataZen organization for having me today. And I'm going to do some questions.
Yeah, okay, now I hear about. Thank you very much, Robert. Yeah, for your presentation, Roland, for your presentation. Yeah, it's very interesting topic, and we really have like a real discussion in our chat. So looks like DuckDB and DuckDB and Huey. Yeah, it's really alternatives for Power BI and Postgres databases. Yeah, we have maybe time for only for one question. Yeah, is it possible? For example, I have old Android device. Yeah, that is just lying somewhere. Yeah, can I start DuckDB on it or Huey on it just to use it for data analysis?
So Huey, I don't know. We have to check. I tried it on my phone, and that didn't work very well because, yeah, Huey is really like, you need the real estate of your screen to really do a useful query. So I'm not sure if on a phone, a tablet would probably work, but the phone, I don't think. But technically, getting DuckDB, yes, that works. And actually, the DuckDB team has recently released a bunch of benchmarks for running DuckDB on Raspberry Pis and on phones. And in fact, they can do a TPCH benchmark at scale factor 10 on a Raspberry Pi. So it's I mean, it's I guess a niche topic, but it's definitely something you can try. And there are people running it on their phones and building applications with that. So yes.
Yeah, thank you very much. Thank you very much, Roland, for your presentation. And thank you very much, guys, for your discussion in chat. Yeah, fortunately, we don't have time to cover all the questions that we collected. Yeah, I think that we will cover them on the talk page in comments. Yeah, so please leave comments on the talk page or in a YouTube video. Yeah, and Roland will reply on these questions.
I will, and you can always find me also on the EPAM network, or just email me, and my email address is in the presentation slide. So I'm always happy to answer questions and talk and discuss them. So.
Yeah, exactly. Also in this description under this video, you can find the link where you can find the presentation and recording file for the session. And on the talk page, you can also award Roland a badge and rate this talk if you like it, or maybe if you don't like it. Be sure to subscribe to our channels for more content like this, and we hope to see you on our next session for Winter Data Meetup. So thank you very much, Roland.
Thank you all.
Yeah. Bye.
Bye.